The question says how many chiral compounds are possible on monochlorination of 2-methylbutane. 2-methylbutane undergoes monochlorination, and in the final product we have to identify the number of chiral centers. Okay, number of chiral centers produced, and how many possible chiral compounds are there. That's also we have to consider. Okay, pay attention carefully. Monochlorination in the sense only one halogen we have to attach to any carbon present in 2-methylbutane, and then we have to find out the possible number of chiral compounds. Okay, first of all we can draw the structure of we have reactant 2-methylbutane. Butane is there, so how many carbon are there in the parent chain? 4 carbon are there. Okay, this is the 4 carbon. It says 2-methyl, to the second carbon methyl group is attached. Okay, now this reactant undergoes monochlorination, reaction taking place in the presence of sunlight, means this reaction will occur through free radical mechanism. Okay, let's say if I attach Cl here, okay, you can see this carbon is having how many hydrogen? 3 hydrogen. 3 hydrogens are there. Okay, so one Cl, one H will remove as a HCl, and one Cl will attach here. Okay, in case if one Cl is attaching, let me draw the structure. Here we have, okay, you can see Cl is attached, one Cl. Okay, so keep in mind this carbon is still having 2 hydrogen, 1 hydrogen, and this is second hydrogen is there. So this carbon will not be chiral center. Okay, I come to the next carbon. Here we have the next carbon is there. Okay, second carbon. So you can see this carbon attached to methyl group, this carbon attached to ethyl group, and this carbon attached to chloride methyl group is there. You can see CH2Cl is there, and you can see one hydrogen is present. This is also different group is there. Hence we can say at least if this carbon is not a chiral center, but we have the chiral center here. We got one chiral center. Okay, now next, if I halogenate, keep in mind, if I halogenate this carbon, so this is methyl group and this is also methyl group, will not get the chiral center. Now I think about halogenating this carbon. Okay, so in case if I halogenate, here we have Cl2 and HV is there. Pay attention carefully. In case if I halogenate, I remove this portion. Okay, if I halogenate, you can see it is having how many hydrogen? It has 2 hydrogen are there. Okay, one Cl, one H will combine together forming HCl. One Cl will attach here. So what is the product we are getting? We have the product. You can see one hydrogen is there and one Cl will attach. Okay, pay attention carefully. You can see this is different group, this is different group, this is different group, and this entire portion attached to the carbon is also different group. Hence we can say this is also a chiral center. Okay, this is also a chiral center. So you can see we got a 2 chiral center. This is also one chiral center, this is also a chiral center. But if I you can see if I attach Cl here, I'm considering the third case. If I attach Cl here, we can consider, let's say if I attach Cl here, so what will happen? Okay, if I attach, let it be 100% only. Okay, so in this case here we have 2-methylbutane, chlorination is there, HV. Okay, if I halogenate this carbon, keep in mind this carbon and this carbon is different. Okay, this carbon connected to CH2, but this carbon is connected to CH. So that's why environment of these 2 carbon is different. They both are first degree carbon, but environment is different. So let's say if I halogenate, it is having how many hydrogen? 3 hydrogen are there. So I remove one hydrogen, one Cl. As Cl is removed from here, one Cl will attach. So we got we have Cl is there. Okay, Cl. Now if you pay attention carefully, you can see this carbon is still having 2 hydrogen. It will not be a chiral center. I cut it. It is CH2. It is having 2 hydrogen. It will not be chiral center. Okay. Now it is C and it is having 1 hydrogen, but these 2 electron densities are same. These 2 groups are same. It will also not be a chiral center. Okay. So if we halogenate this carbon, so chiral center will not get. So you can see we are getting only 2 chiral center. How many chiral center? Only 2 chiral center are there. Okay. Here we got the chiral center. This is chiral center, and here we have 2 chiral center. So you can see we got Option B is correct. Okay, possible number of chiral compounds. If you like this video, please share and subscribe to the channel.